Okay. All right, folks. All right, good morning. Homework, guys. Homework. Hopefully we have some sort of maybe work basis if we need to show work. Some it might not have been so work intensive. Thank you very much. Folks. Are you hold? You hold down here. It makes me really good. You got it? Good to see you.
Okay, y'all ready?
Lazy Michael.
100% folks, love 100% homework. Be happy to give you guys that extra credit. Alright, Toby, let's have Stevie. Alright, number one, if I could borrow someone's sheet, that would be great, because I was going to borrow from the sheet.
I got you.
Alright, number one, and this is an old question. That's why it says number 19. It's like from an old test, like a million, that's not even a word, a million years ago. Which is closest to the width of the wall? And Brianna answered 4 door widths, which would have been D. Agree or disagree, Jack?
Agree.
Why?
Because I drew the thing like she did.
Okay. Drew a thing.
No, I drew the lines like to measure the door.
Okay, so you came up with a measure of the door.
Yeah. And then I copied it. Because it's like from here to here.
Okay. Oh, so you used almost like a benchmark. So you took your finger and used it as a benchmark. Because your finger is not an actual unit of measure. You can't look on in a textbook and or in your agenda and it says finger approximately 50 feet or 2 inches or 5 ounces, whatever it is. So by using a benchmark, I like that. So
and it had a little bit left, and then if you add that little bit with the little bit before the door, it equals.
Okay. Cool. When I looked at it, I found out that the first section of my pinky finger kind of equated to it. It wasn't exact, it was pretty close. So I like that method, and it did fit. That was good. So D is correct. Next shot. The second question, I'm gonna go south here. Which answer, represents a reasonable estimate of the number of 1-foot rulers needed to measure the width of a doorway? So let's get a young lady. You're not young lady. Not this time. Not this time. No young ladies? How about I pick one? How about that? Or Amy, good morning.
I got 3 rulers.
Why?
Because, like, 1 foot, if you measure it out, goes
1 foot would be 3 rulers, you said?
like,
I'm just making sure that what you said was accurate.
okay. Because, like, 3 rulers, I kind of estimated on a door, and, like it up.
So you're just either you're imagining a door, or you're literally going to a door. And I'll use this one because it's kind of more of a standard door. The front door, or that door, is a little wider actually than the standard door. So if you look at this door here, and even if you look at some non-standard measures, like if you look at the tiles on the floor, we know are 1 foot, 1 foot, or 1 square foot. And it looks as though this would be 1 hole, 2 hole. You have almost a hole right there, and then a little tiny piece. From there, you can come up with that guess. But if you're thinking about an actual ruler would go across this door, 3 sounds like a reasonable estimate, whether you're imagining it or if you're physically doing it. So that's fine. That's fine. Just want to make sure that you were able to understand and explain that. Do we agree that D is a good answer? Yes. Something else you want to add to that, Lauren?
I just walked up to the door and used my arm, but of course I slammed my elbow into it.
Of course. He said, of course. As though that was the typical consequence of measuring a door. I measured the door, and then, as in the course of human events, I slammed my arm into the door. That's me.
There was a bird that flew into the
You know, more birds fly into my windows because I use Windex
That commercial.
It's an advertisement. There you go. But, that's okay. All right. Next question, guys. Talking about raisins. Scale shows the weight in grams of 60 fully-sized boxes of raisins. You know, there's a box of, Sun-made raisins in the red box. Well, they're delicious, all that stuff. Which is close to the weight of one raisin box. And you can tell the answer, but I also want to know how you found that answer. Yeah.
I got C 60 grams because it looks like it's about 370 on the scale. So I did 370 divided by 6 boxes of raisins, and I got 61 point. I just
Something.
There.
Yeah, you get something that's not exactly any of those answer choices, but the one that's closest to it is going to be 60, which is answer choice C. Nice job. Okay. I guessed when I found this graphic, I guessed that it was about 370 as well. But someone might just as well say 360, or they may say, oh, 362. Of course it is. They can just make a number up. It's not really as much about finding an exact value from that graphic as it is estimating what you roughly see there. So that's good. Elijah, isn't that?
With measurements and stuff like this, especially on the measuring workbook, also, you can use process of elimination normally. Because I know it's a little more than 50 grams, and 360 is about how much all 6 of them take, and 6 is too small.
I have to completely agree with you. I mean, if you're looking at the answers in a critical way, and I think that we need to. I don't think we should just answer the question all the time. I think we need to look at the answers and the question. And I know some teachers may say, "Oh, don't look at the answers all the time." But I feel like sometimes you have to look at the answers, especially when those questions where it says which. That word "which" is in there too. So the word "which" is kind of forcing you to look at all 4 choices and figure out which one makes the most sense. If it's a good question, there's only going to be one answer. If it's a bad question, well, there are lots of ways it can be a bad question. We can determine that by thinking critically about the answer and the questions. Okay, I think that's good. Last question. Here it is. Using the height of a DVD case. So I guess if we had a DVD case, I had one on my desk, but it's gone. Just imagining the dimensions of a DVD case, like this, kind of like this, the height of it. Estimate the length of a child's arm. Is it going to be 1, 3, 6, or 13? This kind of sounds like a process of elimination question as well, because I think there's some answers there that may end up not making much sense at all. Max?
I think it's 3, because if you're measuring your full arm, 1 won't fit, 6 is too big, and 13 is way too big.
Okay, so 6 and 13 you can chunk out, slash them, whatever you want to do with them, whatever strategy you learned a million years ago. Okay, high five, just give it a high five. There you go. And 1 might be a little bit too short, unless it's like a baby, like a little tiny baby, just came out of the womb, There you go, there's his arm. But, it's real short. 3 sounds like the only reasonable answer here. So. And notice how it's not saying, this measure right here. Remember we talked about some of our kinesthetic measures being, from the wrist to the elbow, that's about a foot. We talked about this being about a centimeter, from the tip of the finger to the first knuckle. First, second knuckle, that's like an inch. There's a relationship there. That's 2 centimeters in every inch. So, did we talk about decimeter? Have you ever heard of a decimeter?
Yes.
Well, thank you. It's in the book. Decimeter is 10 centimeters, and the palm of your hand is about 10 centimeters, or typically. Okay, and I can prove that to you just in case you haven't seen it. I don't remember us discussing that last week, so I want to make sure that you guys saw that. It's a meter stick. Those colors are alternated because all these alternated colors are decimeters. I can prove that. I can, I'll show Toby real quick. Okay, it's all white, 90 to 100, so that's a decimeter. Or from the other side, 1 to 10, it's orange. So if I compare the color to the size of the palm of my hand, it's about 10 centimeters. Okay, it's not gonna work for everybody. Hold your hand out for a second. Okay, so that's a little bit, because you're not fully grown yet. You're still small models, and will be big, adult models at some point. Not like models like this. We did the thing with the yard and the meter, right? So like, yard is about right here where your belt is, and then meter is like a little bit higher. You can do this so it's a little higher. You strike pose. It's kind of, yeah. I'll never do it again. I promise. I'll never do it again. I can't. I promise. I'm never gonna do it again. Today. I'll do this one. Nobody caught this. Tomorrow's Saturday. There you go. Okay. It's not Monday, is it? Okay. All right. Brianna, thank you very much. I appreciate it. Actually, borrow that. Nothing around that. Yes, sir. Question real quick. Oh, guys.
I don't think that the last question was very accurate. Because when I used this, I got 2.
Oh, that's a book though. That's a book though. That's a book though. I mean, I know it has similar dimensions to a DVD, but if you were to hold your arm out, come here for a second. Bring your book, bring your book, bring your book, bring your book. Okay? Also, when we are ourselves measuring something on us, I think we have a little bit of a bias as well. And I don't know if we do the best job at possible because we're kind of working off ourselves. No, where you going? Where you going? Okay. Okay, hold your arm out.
Okay.
Don't care which one. Okay? I'm gonna walk around this guy real quick. Matter of fact, I'm gonna have Carla do it. I'd rather have Carla do it. Okay? No. Get up. No. This is a collaborative effort.
I thought you were supposed to.
No. You go over here, Okay, hold your arm up. So we're gonna do a rough measure here. So he's starting from his shoulder. And he's gonna just put a little bit there. There you go. Got 2. Now, if you go more, so it's pretty close to 3. Now, maybe you weren't counting your, nice guess, you weren't counting your hand. So if you're only counting from your wrist to your shoulder, you're discounting the length of your hand. And if you're talking about your arm, your hand's a part of your arm, is it not? Your fingers are a part of your arm. I mean, like they're an extension of your arm. So, again, there's the misjudgment we sometimes take into body measures. It's okay, it happens. Janai, good morning. Let's put that on my desk real quick. Good morning. Thank you, dear.
This is like a little builder car.
Okay. There you go. Who's up there? Ready. Now, folks, you know that I've been out for several days, and you guys have been studying a little bit without me. We talked last week about the core content of ESCO 6.9, talking about measurement, and we talked about some of the main objectives of that unit. They're on board. They haven't changed. And we're going to continue to study those today. My goal today is not to give a quiz as I initially had wished for several factors. You know that because of math testing that we were finishing. Because I'm not comfortable giving a quiz after being gone for that long because I want to know what you know. I want to understand what you guys are keeping in your head and what you don't have so you can kind of do some maintenance over the weekend. And because we have a test coming up. We have a test coming up next Thursday, and if we are not ready for that, that's part of my responsibility. Regardless of whether I'm here or not here, you guys are taking a test, and I need to make sure you guys are ready. So what I propose is this. On the board, you see a rubric, and there's a weird abbreviation there, WHYL, and it says stations. So it says WHYL stations rubric, and that rubric is used for what I'm going to call, what have you learned? Okay, what have you learned? Okay, you are going to, hopefully by the end of class, be able to prove to me, via the rubric or via whatever you're able to produce as evidence, what you have learned this week and what you have practiced and applied this week regarding measurement. And we know all about measurement now. We're all experts, right? So we probably teach the class, right? Exactly. We don't know everything. I don't know everything. But we should have a decent idea before we leave class, and I will get a decent idea before you leave class of where you're at and where we're going to be next week. So the rubric, and I'll give it a quick read because I want to make sure everybody can see and understand it. You don't have to copy it down. This is just what I'm going to use to grade your work, if there's any work that you presented today. The first characteristic is this, clear, organized information contained in your work. So whatever you turn in today, if you turn in anything, it will have clear, organized information in it. That's pretty easy to do. And I'll let you determine how you're going to do that. There's no other standard by which you need to have work as long as it is clear and organized and it's good information. Number 2, examples match each station topic. So there are 3 groups of us in this class. There are 3 stations, and we'll rotate through those stations today. All relevant work is displayed. So if there is work regarding whatever the station has, then you will show that work however appropriate. If there's no work, then there's no work. If it's calculator based, I don't care. I think we should still have work because we shouldn't let the calculator be a crutch to our progress. And the last one, evidence of collaboration is documented. So if you're working with somebody, document how and who you're working with. Okay? You'll be working in a group. This group is going to be working on a specific task. They may all work together, or they may group up in a small group. They may pair up, or they may work by themselves and then do something later on to show evidence of collaboration. Whatever is necessary, I want you to do. Does everybody understand those characteristics that are on the board? I want to make sure, because if they're not clear, we can fix them. I want to make sure that does everybody agree to them? Sure? Okay, all right, very good. And the values that will be assigned to those characteristics are on the board too. 4, 3, 2, 1, so 4 means exceeds expectations. That means that you've gone above what I expect. Exceeds means you're going above that. So if you're doing a fantastic job of showing your work, or if your examples are just like the best examples that you could possibly make for those, they're not just very basic, low level, low knowledge level questions, then you're going to get that kind of credit. Okay? If it needs a lot of work, then it's going to get on the opposite side of the spectrum, which is a 1. Okay? Meeting expectations is the typical grade. Okay? If you meet expectations for each of those, you would have a 12 out of 16 possible points, and that's 3/4, so that would be 75%. So if you just met the expectations of the assignment, you would get basically a C. Okay? Which is not a big deal, but I expect a little bit of high quality work out of all of you guys. I don't want to put any pressure on you. So just keep that in mind. If you just do what's expected, 75 is the expected grade. If you want something higher, then how are you facilitating that? And then number 2, meets expectations with some omissions. So if you make a few mistakes, I can still give you credit for stuff, but I want to give you the proper credit and give you a chance to fix if you want to fix. And we should always have a chance to fix and learn from our mistakes. If we're not, then we're not doing it right. So what are these stations? I need to kind of tell you what you'll be doing today. Let me find my paper here. Here it is. Anything that we do, you can do on whatever paper you want to do it on. I've got some grid paper if you don't want to use your own. If you have your own line paper, that's fine. But what I want to see station-based is just give you guys probably like about 10, maybe 12 minutes per station. So we're going to rotate these stations and give you a chance to collaborate and talk about and get on your paper these topics. This first, write this on the board. Would this be easier if I wrote on the board? Okay, I'll write this on the board. I'll call it out to you so you guys can hear me and see me too. I should save some work because if I keep calling out every class, I'm going to wear myself out. Who wants to wear themselves out talking about directions? All right, so here are your 3 stations today, and I want you guys to be working in these stations. Number 1, mass versus weight. Okay? So if you're in this station, I want you collaborating, talking, researching, showing me what you know about mass and weight. Okay? That's a huge part of 6.9. We looked at the curriculum framework, and it's like most of the writing. Even though it's not a lot of the math, it's a lot of the writing, it's a lot of the content on that page. So they must want us to know the difference between mass and weight. So I want that to be your burden. We talked a lot about that last week. We got some really interesting video footage. We kind of tied it back to that. The other part of this station is going to be, I'm going to call it sense making, but I'm going to have to explain that. Sense making. And I'll give you an example of what this means. When you try to make sense of measurement units, you have to know something in order to know something else. And I know that sounds kind of silly, but I'll give you an example. Which unit is the longer unit of measure? A centimeter or a mile?
Mile.
So even though those are two different sets of measurement units, you still were able to figure out which one is bigger. So you made some sense of some really interesting, but similar, but also different, measurement units. I want you to be able to explain that in whatever you are documenting today. So hopefully that's not too broad, but I want to make it broad on purpose because I want you to come up with some interesting examples and maybe talk about it in whatever meaningful way you need to. This is a group thing, so if your entire group comes up with an example, fantastic. If it's just one person coming up with an example and you're bouncing off someone else, great, whatever it needs to be. But I want you to be able to make sense of these units. Which one's bigger, which one's smaller, which one has more mass, which one has less mass. Trying to think of some other. Which one has a larger volume or smaller volume? These are things that they like to use as test questions, but when you think about it, they're not as hard as you may think. So making them might be hard, but that's only because I want them to be easy on a test or quiz. Second station is going to be benchmarking. And I know that you guys talked about this several times over the course of the week because I saw some measurements actually on this board when I erased it this morning. And benchmarking, as we talked about in the homework, was talking about how you can use a measurement tool that doesn't have a known measure to in fact measure something else. So if I use my pinky finger to measure the length or the width of my desk, I could do that. I don't know what the measure of this is, but I could say that, okay, well, my desk is 1, 2, 3, 4, 5, 6, 7, like 7.5 pinky fingers long. That makes no exact measurement sense, but this gives me a rough measure of what I have and what I'm measuring. So benchmarking, I want you to come up with some good examples, talk it out a little bit, maybe talk about your experience this week, make up your own examples, pull some examples from whatever you've done. Show me what you learned. What have you learned? Last station, easy stuff. Last stuff. And this is the one that might give a little bit of a fit, but I'm going to let you guys use whatever resources necessary to make it work. Estimate conversions, but they have to be multi-step. Now, what does that mean? Remember those examples we talked about at the very beginning of the unit? It was like liters and gallons. It was like, Mom's taking to the store and she said, we need to buy 2 gallons of soda. You can't buy 2 gallons of soda from the store. Don't sell it like that, do they? How much soda do you have to buy if Mom wants you to buy 2 gallons of soda?
4 bottles.
For
2-liter bottles.
4 2-liter bottles, which is about 8 liters. So it's pretty darn close. So why is that multi-step? Well, think about it. You have to know what a liter is compared to maybe its constituent customary measure. A liter is about the same thing as a
quart.
Okay. Well, you have to know how many quarts are in a gallon as well, right?
Yes.
Gallon man coming to mind. Big G was on the board this week, and you guys already knew that from 4th, 5th grade, and even 3rd grade. So you have the information necessary to do a multi-step operation, talking about estimating between different conversions. Okay. Different systems. So what I'm asking you to do is to show me what you've learned this week. What have you learned last week? What have you learned this week about measurements in those stations? I want you guys working on mass and weight for the first 10 minutes. I want you guys working on benchmarking for the first 10 minutes. I want you guys working on estimated conversions between metric and customary. Okay, make sure that they're kind of a multi-step basis there. Okay, can you work together? Absolutely, I want you to, guys. I want you guys collaborating. Part of the rubric, okay? Show that you're collaborating. Show some good work. Pull from different resources. You guys have 10 minutes. I'm going to put a 10-minute timer up. And after the 10 minutes, we'll switch the roles. You guys can stay where you are, and we'll just shift the roles. You guys can work from there. But you're going to come with me too.
Okay, what about this? Like, how many? Okay, what if like we do something like centimeters on our side of no, how much centimeters on our side of foot? Something like that.
She's too much.
Okay, how much? Okay, no, how much yarn?
Go to your agenda. Go to your agenda.
It's
2 kilometers. Why are you? Yeah, we're community. I mean, we're democracy. You guys can be community.
Are we making questions?
No, you're common.
Clear organizing.
Yeah, we're the West Germans.
In your mouth.
We're West Germans.
We have to do sense making of many
Yeah, we're East Berlin Wall.
That's what we're doing.
10 blue down to 6 is equal to how many?
Wait, so if we go to
Blue down to
go over there.
More than 8.
8 out of 16, you get a 50, so you get a 4 off, and then you have to get
You get a 4 off and then 100.
Cups and 10 gallons.
That's the same thing as the boats. Because those are both the same kind of metric. Trying to like do metrics is customary.
the maximum. Yeah, you size 4. 4 times 4 is 120. Okay. Now, how are we today?
Oh my god. Oh, I didn't.
3 miles.
And I'm leaving you a code.
Do we have to do the questions?
You realize it's estimation?
Well, I estimate that it's going to be.
I'm still just there. Here.
I estimate that it's going to be. Kilometers a half mile. About 16 gallons. Kilometers about half a mile. A kilometer is about half a mile.
It says, capital K, capital B.
2 kilometers.
What kind of resources you guys pull from?
2
times 25. Make the question.
What's the silly 5
We have to do 2 times 25.
Put a lot in there. I'm wondering if like in the second page, if actually we're not into it, like it's in book or something. I don't see it. I don't see it being much of a Think about what we had talked about, like Martian gravity is like 1/3 of Earth's gravity. So if you weigh 90 pounds, what's 1/3 of 90? Maybe that's a way to kind of apply 1/3 of 90. So like,
So it would only be 520.
So 1/3 times 90, and maybe you can tell how much you actually weigh on Mars. Lunar gravity is 1/6, so you can maybe put the weight on there, make it more meaningful. Sure. This is a collaborative effort, so you guys can do whatever you need to, as long as you fulfill those characteristics. You know, if you have clear organized information, are you guys collaborating? Who are you collaborating with? It's always good to know. I want to know because that's going to be my documentation to give you guys credit. So, are you showing work? So, if you're answering questions, are you showing work? If there's work to be shown, with benchmarking, how about you guys answer each other's? So if you make one or he makes one, or if you're all making one together, that's fine too. As long as you guys are collaborating, that's where it's at. So.
Let's go to this. Let's make a question to know how many kilometers on the
estimate?
Answer this. Yes,
This is actually pretty darn easy.
So, Aaron,
Well, you can answer, you can use a why after that and say, you know, I know that.
oh,
it's
you're actually writing word problems.
smaller than an inch or an inch is larger than a centimeter because, you know, and I can use my body math to explain it. I can use an actual conversion reference, maybe from your blue book or your agenda or your textbook to back that up. Whatever it needs to be. You know, you can make one example, make two examples, whatever it's going to convey the point and understand what that means. How do you make sense between movements?
I made a word problem.
You're comparing.
Wait, how are they moving? I don't get it. Because you have
Absolutely. Absolutely, yeah. Body math, guys. Body math is great.
What you have to do is you have to
How you guys doing? You guys doing anything? You guys get some examples too? And whatever you have, make sure that if there's any work needs to be done, you know, show it, talk about it, you have collaboration through. Well, we've got about 3 minutes and 52 seconds. So, what we'll probably do is this. We'll do 10-minute sessions. And then we'll do like, you know, we'll do kind of like a short session at the end. So you can together whatever you need to tell up there. And then we can share out.
You know, like 0.95 or something?
Lockdown?
It's estimating.
let's do 2
Hey, what's 1 mile?
No, a mile is slightly, no, a kilometer is slightly farther than half mile.
It said 1 mile. 1.5 kilometers onto it.
Yes, that's what I mean, so that means that maybe 1.6 kilometers.
I can't read it. I can't read it.
I'm switching how many Oh my god, I hope it's clear.
That's clear.
Yes.
This looks like a bunch of this.
How many folded bottles is equal
Well, you need to help us out because I feel
Check each other's stuff. If you're doing things separate, check each other's stuff. If you guys are directly working together on anything, which is good. So,
What you're saying
go ahead.
is that you can more children, you're saying they need half the
One quarter, that's all. Interesting. Yeah, so that's a good benchmark. It's a good estimated measure. You don't know how long that is. Now you can turn it into a measuring tool if you want to, if you knew how long that actually was. So if it was 15 centimeters, you know, the 32 1/4, that's a good benchmark measurement because you don't know what that is. But if you know what it is, could you find a more accurate measure?
That's a good question. 32 pounds of corn. How many kilograms does he eat?
Those aren't cheap. I'd use centimeters. So what can you do with what you know about this and this?
What are two You just back up the It's 50 burgers. It's 50 pounds of burgers. It's actually 2 quarters.
No. How many pints?
Okay, so it'll be about So interestingly enough, two comprehensions of this design would make about a foot. So what could you tell me about the
But I forgot, how many,
based on what you just told me?
wait, how many miles?
It's great.
How many foot are in miles?
It is? No, if you order now, 5 tomatoes, 5 tomatoes, 8
Is
it a multi-step one?
Isn't it like 1,500
Oh,
something?
sure. I was actually paying attention. No.
Yeah, okay. Alright, pause for a second, guys.
How many miles are, how many feet are in the mile?
So you can say 16 minus 2 So show that. Alright, ladies and gentlemen, can you hear me clap twice? Close enough. Okay. What I'd like to do is have you guys pause on where you're at now, and I want you to go to that next station responsibility. So we're going to rotate the responsibilities. Do you feel it easier to literally move, or just to move the responsibilities? Okay, if you're comfortable, that's fine. I'll allow that. That's fine. So how about we'll switch now? So we're going to rotate our responsibilities. So you guys are working on mass versus weight, correct? Okay, so we're going to work. You guys are going to do mass versus weight. You guys were doing benchmarking. So the gentleman and the lady over here, we're going to do some benchmarking. You guys are going to be talking about multi-step estimated conversion. So what have you learned? That is the rough question I'll give you. I'll let you guys explain that with your findings. If you didn't finish your current station work, that's okay. We're going to come back to it. So just leave some room. If you got to go to the back or get on the piece of paper, that's fine by me. And then we'll get our next timer out there. Your 10 minutes has started. We'll do a last session to cover everything we need to finish up. Make sure everybody gets at least a time to get each other.
I'm gonna do like the last
Give me an example.
This is one decimeter.
No, a decimeter is just the palm of your hand.
I know, but
You're not long.
so from this.
But not ruler.
Yeah.
Yeah, but in the book
I
it
didn't know
says
that. I didn't know what I was doing.
This is about 1.5.
I said I wanted to measure the width of this table. I knew that this doorway.
Okay, we got
15 calculators across. I need to get this together. So, well, this table
I should say right down the
Alright, I'm gonna go measure the chalkboard.
So maybe
Hey, Keegan, for benchmarking, all you gotta do is just do the body measurement.
So first, like, say what part of body part is what, and then like put examples of certain measures.
I did height of computer in centimeters and converted to inches.
So using a benchmark allows you to make decisions based on whatever.
No, only
I'm doing it just to
So it's
exceed
not meant to be really
get better.
fast, heavy, or really difficult. It's just meant to be something that you might use in place of you know how long measuring tape probably better. But you know, how can you make these measurements if you don't I'll give you an example of a hand. It was actually it's a real adult male hand.
So that's how yeah, but I got sad looking like that. Like it was.
Probably the guys need to have a hand.
Yellow and chalk.
You don't care.
Remember the example we talked about the radio unit, meters and gallons?
Hey, Caleb, how many questions do you have?
How that was an example of using one step to come up with it.
No, for bench marks, you gotta like, you don't have to draw it. You just like, show a bench mark and
We're gonna use ones that we've already used. We're talking about making one together. And I see people work together, and I see people kind of working apart, which is okay. Just make sure you're making your own measure. It's got knowledge in there. It's improving what you know. If you didn't know, you found information because it's something that you can use. So the other point of looking at is for us to kind of pull information from sources, whether it's each other or from whatever, or from our own head, and put it into something that we can use, where we can make refresh memory. So it's almost like making your own machine.
Alright.
Wait, what would be your? What is there?
This is yours. I got 30.
I thought that was
Wasted now.
That was
What
me.
you guys doing?
But what's the difference between a meter and a yard?
I think making
Oh yeah, what's it like? Meter supposed to be like right
but
here.
if you think about
many questions have we made?
gravity that you can experience, or that are
Wait, not supposed to like questions.
then you have the way to Martian gravity is only 1/6.
No, we're supposed to measure.
Martian is 1/3. Lunar is
No,
1/6.
I'm supposed to like measure.
But
You're not supposed to like make questions, but like you're supposed to be like, what's the height of this? What's the?
oh, you did it. Oh, you do it. Oh, well, then I don't want to give it away. But if you guys need help, let me know. What's up? My best estimation is that Jupiter is about 2.5 to 3 times the force of Earth. Now, Jupiter is really, really big, but it's mostly gas. So it's what we call gas. So, to be honest, I really don't know what the core or what the solid part of Jupiter looks like, feels like, or whatever. That's something that I would have to say further. And I read the question, the same. But in what reading I've had experience with, it said it's like 2.5 to 3 times the force of Earth. So if you were 100 pounds, you would weigh
In decimeters?
250 to
So I'm about-
pounds
And what?
on Jupiter.
Okay, so I'm about.
Now that's just
Okay, yeah, you can do that.
standing on something. Because you have to imagine you're standing on something.
I'm gonna do the height of the chair.
6.5 feet.
I like thinking about Martian gravity and lunar gravity because there's way less. It's yeah, so that's pretty sad. That's why NASA actually works on not only space science stuff, but also earth science stuff. You can't really be expected to be able to go somewhere and live like in another another planet. You don't really understand your planet. Because there are a lot of places on our planet that are very similar to other planets, but we don't know because we have
How do you spell height?
It's 14. This is the
Hey guys, doing? What's going on here? I'm just curious. Anyway. If you weigh 927 pounds, holy moly.
Thank you. That's what it takes for this.
If you weigh 100 pounds on the and I mean, look, if your mass was 100 pounds, for lack of using metric. So the gravitational pull on the moon is about 1/6. So it's like 16% or 17%.
Yeah, I weigh 15
So then if you were to multiply your weight by that gravitational, that'd be pretty rough. I would say closer to like, if you were to use, if you were to use calculator, I would type, 1 divided by 6.
This is
And you get a repeating decimal. It'd look like 1600s, but the 16 piece over and over again. And then multiply that by whatever your mass is. There you go. So by multiplying that times your mass, that would be a rough estimate. Here you weigh like what? There you weigh like 14 pounds, right?
I weigh 14 pounds.
Yeah.
On the moon, I weigh 15.
So there you go. So now maybe explaining why that would be interesting. You know, like, what would you be able to do if you're on the moon? Or what? You're not doing that. Well, if you had a spacesuit on, accounting for the spacesuit weighing or something like that, having some sort of, mass itself. Would you still, would you be able to walk? Would you be able to run? Would you be able to do this, that, and the other thing? There's some interesting things that you're thinking about. Mass is two things. Mass is constant, weight is variable. And that's the big, curriculum point that I want you guys to make. But also, the fun part, have fun with it. Have fun with it. How's going on, guys? I talk to you guys a lot. Max's head is 20 inches around. Now, were you using an exact measure, or were you estimating?
I used my watch, which is 9 and
9 and then 2 fingers. 9 what?
9 inches.
So it was 11 inches?
No, we estimated 2 watches.
Okay. Interesting. So you measured the watch, which was basically a benchmark. I guess we call it a benchmark. And where did the 2 fingers come from? So you did like this, or you did like this? Okay. So you have 2 of these. So 2 watches and 2 of these. Okay. Interesting. You already did. Hey guys, can we pause for just a second? Right. I had some very in-depth conversations about mass and weight over at the chalkboard group, which is great. I like when you guys are talking about stuff. I like when you guys are doing stuff. I saw these guys laying on the floor. Wow. They did clean the floor, so that's a good thing. So, and the boys want to do that. They like to get dirty, sit on the floor. We'll let the boys do the dirty work, right? Always do that. Say, boys, come here and measure this for me. I'll write it down. Yeah. I'll be the note taker. Okay. All right. Last rotation. So the one you haven't done yet is the one you're doing now. So mass versus weight. I think you guys are mass versus weight.
Yeah.
Okay. So have fun with that. Get into that. Benchmarking, which is non-figure measures. Estimated conversions. So we're talking about how can we make sense between the measuring and customary systems, but how can it be a multi-step operation? We're not just talking about miles to kilometers, or I'm trying to think of another really interesting one. Inches to centimeters. Did I say that right? So think about how it can be a multi-step operation. That's where our understanding needs to be. Liters, gallons. We did miles to meters, I think, at the very beginning of the unit. So how are we going from one unique measure to another unique measure, and how is it sometimes leading us through multi-step situations? Okay, I'll put some more time on the clock here, and I'll let you guys on that for a few minutes, and then we'll try to finish this up, share it out a little bit, give you guys something to take home.